Hello and welcome to Notebook. Have you ever wondered about the number of changes occurring all around us, like melting of ice, chopping a log of wood, burning and melting of a candle, burning of wood, rusting of iron, curdling of milk, rotting of fruits and vegetables, etc.? In Class 9 chemistry, we had studied that there are two different ways in which a substance can change: physical and chemical. A change of appearance without a change in the chemical composition is known as physical change. In the melting of ice or candle and chopping of wood, the physical appearance is changed, but the chemical composition remains the same. Whereas when the candle or wood is burnt, iron gets rusted, fruits and vegetables get rotten, these undergo a change in the chemical properties to produce new products. Physical changes can be reversed, but chemical changes cannot be reversed. In this video, we shall learn what leads to the chemical change. We shall also study chemical reactions, its identification. Chemical changes are the result of chemical reactions, the processes in which a substance or substances change into a new substance or substances with different chemical properties are called a chemical reaction. Let us take an example. When a piece of limestone, which is made up of calcium carbonate, CaCO3, is heated, it breaks down and forms white residue of calcium oxide, CaO, and carbon dioxide, CO2 gas. When a small piece of the soft metal sodium, Na, is placed in cold water, H2O, it undergoes a small explosion, making this a thermochemical reaction, which is a chemical reaction in which heat is exchanged. What happens is sodium, Na, reacts with water, H2O, to form sodium hydroxide, NaOH, and produces inflammable hydrogen gas, H2, which is ignited by the heat released in this reaction to cause an explosion. Here, the substance which undergoes a chemical change is called the reactant. In the burning of a candle, the candle would be the reactant. In rusting of iron, iron would be the reactant. In this reaction, as calcium carbonate, CaCO3, changes, hence it is the reactant. Similarly, in the reaction between sodium, Na, and water, H2O, to form sodium hydroxide, NaOH, and release hydrogen gas, H2, sodium and water are the reactants. And the substance which is formed due to a chemical change is called the product. In the burning of a candle, the evolved carbon dioxide gas and water vapor is the product. Whereas in rusting of iron, the rust formed on the surface of iron is the product. In this reaction, as calcium oxide, CaO, and carbon dioxide, CO2, are the new substances formed, hence they are the products. Similarly, in the reaction between sodium, Na, and water, H2O, to form sodium hydroxide, NaOH, and release hydrogen gas, H2, sodium hydroxide and hydrogen gas are the products. So, we can say that a chemical reaction is a transformation of reactants into products, where reactants are the initial compounds and the products are the final compounds. Like in the reaction between reactants hydrogen gas H2 and oxygen gas O2 forms water H2O as the product. This brings us to our next topic, identification of chemical reactions. There are some characteristics by one or more of which we can identify the occurrence of a chemical reaction. Evolution of gas. Some of the chemical reactions occur with the evolution of gas or a mixture of different gases. Some gases like oxygen, O2, hydrogen, H2, and carbon dioxide, CO2, are colorless and odorless, where some like ammonia, NH3, and sulfur dioxide, SO2, are colorless but have a distinct pungent and choking smell respectively. A gas such as chlorine, Cl2, is pale green in color and has a choking smell. Let us take an example of highly active metals which in reality displaces hydrogen from acids such as zinc and magnesium. They react with dilute acids and pale yellow oily acid with evolution of hydrogen gas, which can be checked by holding a lighted splint and results in burning with a pop sound. When lead nitrate, PbNO3 is heated, it breaks down into yellow residue of lead monoxide, PbO, and evolves a mixture of a reddish-brown acidic nitrogen dioxide, NO2, and colorless oxygen gas, O2. Formation of precipitate. Sometimes, when solutions are mixed, an insoluble ionic solid gets separated from the solution. This solid is called a precipitate. Let us take an example. When an aqueous solution of sodium sulfate, Na2SO4, a white solid which is highly soluble in water, is mixed with a solution of barium chloride, BaCl2, a white colored precipitate is obtained. What happens is sodium sulfate, Na2SO4, reacts with barium chloride, BaCl2, to form a white crystalline precipitate of barium sulfate, BaSO4, in sodium chloride, NaCl solution. Change in temperature. In some reactions, heat is released, and in some, heat is absorbed. They are either exothermic or endothermic, respectively. Color change. Some chemical reactions take place in such a way that the color of the product is different from the color of the reactant. Many biochemical reactions, like change in color of leaves with the change in seasons, and reactions involving corrosion or eating up of an outer layer of metals with the action of air or moisture, are examples of such reactions. The water of crystallization is the water molecule present in the salt structures without reacting with the salt. The best example of this is light grey powder anhydrous copper sulfate, CuSO4. When copper sulfate gains 5 molecules of water as the water of crystallization, the color changes to bright blue, and the salt is known as copper sulfate pentahydrate, CuSO4.5H2O. Change in the physical state. Many chemical reactions occur with the change in the physical state of the reactant and products. Like the burning of a candle leads to the formation of colorless and odorless carbon dioxide gas, CO2, and water vapor, H2O. This brings us to the end of this lesson video. Till then, keep well, keep studying, happy learning.